Okay, this problem starts with the word initially, so you might think we need an ice chart, but we don't. Because all they're asking us to find is Q, I'm allowed to take the molarity values they give me, or if they were moles, I'd turn them into molarity, but take the given values and just plug them in as if we were finding Kc. It's just not called Kc because we don't know if these are equilibrium values or not. Kc has to be at equilibrium. So I set it up the same as Kc. Products over reactants, coefficients become exponents. Plugging the initial, the given values in, 0.4 to the fourth over 1.2 squared, 1.2 cubed. Plugging this in, I should get a Q value of 0.01. Now, in order to say if it's going to shift left or right, I'm comparing this Q value to the given K value, which, by the way, if you don't have context for this number, you can have your calculator take it out of scientific notation for you. But I'm comparing 0.01 to 200. Q is less than K. Q is too small. That means my products over reactants as a ratio, as a fraction, products over reactants is too small. Now mathematically you can look at this in terms of the numerator or the denominator. I always, 100% of the time, look at the numerator. So it's the same thing as saying my products are too small. If I were looking at the denominator, I'd have to say the denominator is too big. That's why I think this is easier for people. So if this fraction's too small, that means my numerator is too small or my denominator is too big. But my numerator represents the product, so that means my products are too small or I have not enough products. Not enough products means I'm going to need to shift to make more. I'm going to shift to the right. Or you can think of it as a whole on the product side, not enough. Shift right to fill it. In terms of your explanation, saying that Q is less than K is needed, saying there are not enough products is needed, and then telling me to shift is also necessary.